This conference will now be recorded.
Hi everyone, welcome to the AWS training program. So yesterday we talked about two services, that is SNS, simple notification service, which is used to send some notification in case something fails, something successful, or any other type of event can be there, which you can configure and we can send the notification. That can be in the form of email, that can be in the form of some chat messenger like Slack, or can be SMS, or it can be integrated with some other services as well. After that, we talked about SES, that is simple email service. So you can verify your identity with AWS, and after that AWS can send email on your behalf. That means if suppose you are running a job every day and at the end of the day you want to send some report, but instead of Amazon email ID you want to use your official email ID or some other custom email ID, so that can be used for that. And SES is completely like scalable and flexible, so it can send mail to millions of users at a time. That's the benefit of SES. So these two services we explored yesterday, and the remaining two topics, that is SQS simple queue service and SWF simple workflow service. These two services we will be exploring in today's class. Okay, so let's start with the agenda. So the agenda is like overview of SQS simple queue service and overview of SWF. So we'll explore theoretically, we'll try to understand the concept, and I will show you practically on my AWS account. So let's go to SQS. Sorry, here. So SQS is a fully managed message queuing service that enables you to decouple and scale microservices, distributed system, and serverless application. Let's make it simple to understand. Suppose there is one application which is generating some data, and it's generating some data at very fast speed. Every minute it's generating some, suppose 100 MB of data. But the receiver application that is not capable of handling that 100 MB of data per second. It cannot do that. Now what should we do? Because the first application, the producer, it will keep on generating data, lot of data, and the another application is not equally capable as the first machine, as the producer, right? So in that case, what we will do, because after some time your data will be start losing, because your reducer, or you can say your consumer, will not be able to handle that. So in order to decouple these two applications, what we can do is we can manage some in between some queuing service. For example, suppose you ordered something from internet, right? And some delivery guy came to deliver at your place, but you are in office, you are not at your place. What he can do is he can put that parcel into your mailbox, or maybe there is an other place where he can put it, right? And then as and when you are coming back from office in the evening, you can collect your stuff, maybe from the reception of your office, something like that. So between the producer and consumer, there can be some storage mechanism which can hold your data for some time, not forever, because that's not a good idea, right? But you can define some limit that, okay, my queue should be able to hold my data maximum for 5 days, maximum for 1 month or 1 year. And your consumer, as per their own speed, as per their own convenience, they can, I can say, pull the data from the queue and they can process it. So they don't have to process it immediately. There is no pressure that I am generating this much of data every second, so you have to process the same data at the same speed. That's not required. So it eliminates the complexity and overhead associated with managing and operating message oriented middleware. Prior to AWS, there were many more applications which are doing the same functionality, but there you have to manage all the infrastructure, like where exactly your MQ, there is a service MQ, messaging queue. MQ service is running. There is a Rabbit MQ as well. These are not AWS specific. I'm just talking about the messaging service. So Rabbit MQ is there. These services were doing the same task, The only difference is that you have to manage the infrastructure, and suppose scalability, right? Suddenly you started getting lot of messages or lot of heavy traffic, then that may not be capable of holding that data. So if you are going with AWS, since it is flexible, since it's scalable, it can hold any size of data. It can scale down or scale up as per the requirement. So using SQS, you can send, you can store, and you can receive messages between software components without requiring other services to be available. As I was giving that example, like some delivery guy came to deliver your parcel and you are not available at that time, but that's still fine. He will put the stuff somewhere at the reception, and later on you can collect from there. Similarly, when your producer is producing the data, at that point of time, if your consumer is not available, that's absolutely fine. Your SQS can still hold your data, and as and when your consumers are available, that can be single, that can be multiple, because there can be multiple consumer and they can pull the data from your SQS and they can process it. So they can process it later. It's not like immediately required. So these are few points related to SQS, how to create it, how to use it, that we will be talking about. But before that, in case you are having any doubts till now, you can ask me. Okay, so the next is create a SQS queue. So what is that? How to create it? What are the other factors of this? Let's do that live. So I will be opening my AWS console and I will go to SQS. So we'll open it. Simple queue service. So this one was created by me for taking the screenshot and all, but I can delete that. We'll be creating again. Okay, that's good. So now there is no queue in my AWS account and we can create a new queue. So we'll be clicking on create queue. So the most important thing is what type of queue you want to create. So you can see here, at least once delivery, message ordering is not preserved. That means if your queue has some data, right, it can have duplicate data as well. At least once delivery, that means at least one time your message will be delivered to your consumer, but it can be delivered even more than once. Sometime you might have noticed that we got some bank notification about some withdrawal or some other transaction 2 times, right? So that is fine, 2 times is fine, but we should get the notification at least once. And another is best effort ordering. The messages you are receiving may not be always in sequence. So you made 3 transactions on your account and you are getting SMS for the third transaction first, and after that you are getting the SMS for first and second transaction. That can also happen, but that's absolutely fine, right? Because it's ultimately to intimate you that this transaction has been made in your account. But that's not always the case with all the use cases. If I talk about some another use case like order processing, right? So if there is a order processing, and suppose you are sending this event to a order processing team, sorry, some order processing unit, right? What they will do is they will pack your order and they will start the, you can say, delivering it, right? If you are doing that multiple times, I mean, instead of once, you are doing multiple times, that's not good. So in some use cases, we strictly want only one delivery, and moreover, we also want the sequence of events that needs to be preserved. You cannot mix them. So accordingly, we can choose our type of queue. So you can see here, first in first out delivery. For example, some if you're going to some hospital or maybe some submission of jobs, for example, you submitted a job, at that point of time none of the resources are available. That means your job is submitted but not started. After some time, another team member submitted another job. So the sequence in which you are submitting the job, accordingly it should pick from the queue, and accordingly it should execute the jobs. So here the ordering is very important. Ordering and the priority needs to be maintained. So in such cases you can go ahead with FIFO queue as well. Okay, so let's go with FIFO and we'll give some name. I will give my FIFO queue. Okay, now come down and we'll see, like you can see here, visibility timeout. Like your message will be visible to other applications, because immediately you don't want to I will tell you an example. Like you put some message in the queue and immediately you don't want to process it, because behind the scene you want to put a delay of 5 seconds or 10 seconds, because suppose you made some